Hello, I'm Ellie. I'll talk today about a faster way of pip installing um, Python packages, inspired by Talk Python to Me interview that I just listened to, and I said I must try this out. So there are a few ways of installing Python packages. Some of them everybody knows to do: pip install, pandas, or whatever. You can do so conda install, pandas, whatever. There's something like pipx, and there's quite a few others. And now there's UV, and I would like to try it out. And of course, you know me, what I care about is will it work within Azure Machine Learning or not? So the talk itself was very, very interesting. I strongly recommend going and listening to the whole interview. I'll have the link to it in the description of this video. And what caught my attention was this is supposed to be significantly faster. It's all re-engineered. A lot of thought has gone into it. In the future, I suppose if this will catch up, probably there will be even more features and capabilities beyond what just pip does. Probably the discussion is more relevant to people who are application builders and software developers. For a data scientist who's using Azure Machine Learning, the relevance is that when you use, let's say, Azure Machine Learning pipelines, and each component sets up its own container, and within the container, a conda environment, and then pip installs all the different packages, reducing the time you need to wait between each container the time to set up the container is of great benefit, especially when one is parallelizing processes. So the first question I was asking myself was, can I actually get this to work within a conda definition? From one YAML. Most of the way I work when I define an environment is here's a YAML environment, and then I create it, and it's also when you now also within the definition of Azure Machine Learning component or a pipeline, you can just say, hey, look, there's the YAML file. Use that to define the conda environment. And I really was curious. So if I do it within Azure Machine Learning, will I really get improvement or not? I mean, especially if you're going for the YAML. So if you're doing for the conda environment, so you're taking all this time to set up conda, does it really make a difference on the times afterwards to add a few more packages? Because most of the conda packages come with the environment, with the conda definition itself. So let's have a look. What did I do? So this is the way I everybody defines conda environments using a YAML. So you give it a name, you say, oh, these are the channels I'm looking at, a few very key important dependencies, and of course pip is important. And then you say, oh, here's the pip installs, and you can either do it from the requirements or just list them here. And I'll say, okay, let's put UV here and see if I can get it to go. I'm not going to show you my experiments because basically I did not manage to do that. There's no way to. So there is a way with some post processing if you do it really cleverly and jump through hoops and hold your hand behind your back. Basically, there's not a way that is easy for non-Python sophisticated experts to do it. The only way to do it that I figured out is you just create a conda environment, which is a vanilla conda environment, and then you do in the next step within a bash script the installations. So I've created two bash scripts. One will be just ensure that I don't have a previous activation there, just to be clean. Create a conda environment, and the definition that I have is for Python 11, and all it has there is just the basic conda, and then I activate it. And those of you who have tried already to do activation from Bash, you know you need either to do a conda init, and sometimes it works, sometimes it doesn't. But this is a way to get an activation within a Bash script. When you run this, it will tell you that it's deprecated. Um, and then here I go. I do a pip install all my requirements, and my requirements file. I deliberately took one of my longer ones, not the longest, but there's quite a few here. And because it's also Azure Machine Learning, I included a few Azure Machine Learning packages that I usually use, the SDK2. And the difference between this file and this one is that, first of all, I installed the UV package itself. Another issue that I have is when you go to the UV GitHub in the README, and also in the discussions, oh, look, there's all these ways of installing UV, and the recommendation that he gave there was do the curl, and actually you need to do it once per compute. But I had a problem where I did not have the rights to run the whole installation. Although I did a sudo and I am the owner of the resource group, I'm not sure where it hit an issue. But you always can do the install, right? You can just do this one, and this is what I did. So I installed the package itself, and that brings in the UV capability. And from there, you can just say, okay, instead of pip install requirements, I do UV pip install requirements. And let's see how the timing look. And before I talk about the timings, have a look at this. So here's my terminal window. You can see I'm just running the first. This is the pip experiment. It's creating the conda environment over here. It took, I'm using the time, you can see it here. Let me just show you again. I'm using time to give me the timings. So the conda itself took about, in this, what you see here, it's about 33 minutes. Beforehand, when I tried it before, and it was 29 minutes ish. So it's around half an hour. So half an hour, 33 seconds, sorry, to get it to go. And you get all these messages. Of course, you can turn, sorry, this is when it's done. And then it starts doing the pip install, and you get these messages from the pip install. And I was quite pleasantly surprised that when I got to the next experiment, yeah, so this is the pip ending with a lot of messages. This particular one took 2 minutes and 57 seconds. That's also, the previous one was about the same time. And then I go and do the UV step. So the conda step, of course, is about the same time. No surprise there. But look at the user the output. And actually, when I run it, maybe I'll just run it for the fun of it. You'll see how it looks when it runs. I'll just run. Hang on, so I need to activate the environment, right? So I don't think it's activated. Let me just see. So the output is really nice and neat and elegant. Go clear first. Yeah. Yep. And I'll obviously edit out the wait for the conda installation itself. Yep. Look at that. Look how lovely it is. Oh, and there we are. Now that means that if I can't define, if you watched my other video around parallelization, when I defined the components, I had within each component, hang on, this is not the right one, it will be in exploration, the bird model, right? In the components, I had within each component, I had a conda yaml. So I can't really do that. So what I need to do is in the environments, I need to define a custom environment that has a proper containerization definition, and then within the script do. So if I'll show you just what I mean. If I base it, and for instance, if I'm not mistaken, the scikit one would be a good example. Look at this one. So the scikit comes with a Docker file and a conda dependencies, right? So if I go into the Docker file and I'll define here, please create for me a conda, and then I run all the pip installs from the requirements here, then I'll have an environment which I can use within the pipelines. I'll just say, use this particular environment. So if I go back to the summary, so I cannot get it to work within a YAML. So that means I can use the way around this is to use a custom environment and do a regular pipe. Actually, if I'm doing it this way, I don't really need conda. If every component, usually when I work with components, I really need a small number of um, packages per component. So the question is, why do I need a full conda each time I go for a component? I'm wasting a lot of time. So from now on, what I will try to do is I will just define my environments that I need for this particular container without conda. I could not use the curl. If somebody can enlighten me how to get it to work within the Azure Machine Learning, maybe I can put it as a init in the startup of a particular compute. And I didn't show you the timings, or maybe you already saw it on the screen, but let me show it to you again, if I did, because I didn't make a big deal out of it. So when I did the pip job, the conda took me about half, 30 seconds, and the pip took about 4 minutes or 3 minutes in this case. And then on the UV step, of course, I did one pip install of the UV itself, and then the UV step itself. So you do need to take them together. But this was the same time for conda. And when you take these together, this was about a minute. Really intriguing way of installing packages, and I'm definitely going to continue using it as I go along. I'll encourage you to go and listen to the full Talk Python to Me discussion. Thank you.